So after a long time, we are resuming part two. So in part two, there are almost 10 sections. Out of 10 sections, first section is a real-time configuration of Exadata. So this is already complete. It has 8 lectures. And next is monitoring part. In the monitoring part, we have 9 lectures, 2.9. So 2.7 until 2.7 we have completed. Now we need to complete 2.8 lecture 16 active requests, alerts and metrics, and lecture 17 IPMI, DMI decode and ADR. So today now we will complete active requests, alerts and metrics. So what is active request in Exadata, and how frequently we come across these active requests in our daily day-to-day life. So to speak with you, honestly, in your day-to-day regular life, DMA life, you will not see this active request. Nobody will go and see. But as an exaggerated DMA, you need to know what does it mean, active request, what are alerts and what are metrics. Because in the interview, you may face these questions. Interviewer, maybe he will ask you what is active request and what are the alerts in Exadata and what are the metrics. Alerts is fine. The alerts I will tell you, this is even in your regular life you will see the alerts, but active requests and metrics, it's very rarely you will see. These three things we will complete today as part of lecture 16. So I'm sorry. So active requests, what does it mean? Active request is nothing but it's a active request provides a client centric client IO requests that are processed by the cell. Means, let us say Rman is a client. Rman is taking backup. So that will generate a client IO. Rman is a client connecting to the SQL Plus database, and it will take the backup, right? So that generates a client IO, and that IO will be fetched from this cell via database node. It will go and sit in the backup media. So this is how it works. So we can generate some IO using Rman client, and we can see whether it is processed by a cell. So for a cell, that is the active request initiated by RO, and the action item is the action that is being taken place is client type. Client type. So this active request is like a view or table in our SQL Plus. You can describe in cell CLI. Let us say active request display copy, and you can go to any cell CLI, right? So active request, if you see the describe active request, this is like our table, describe the table, and you see the columns, right? These are all attributes. Okay, so this is a active request view, or like a table, and these are all attributes. These are all attributes. Now let us go and see uh, we will generate some active request now. See, sometimes in the test lab, because our mission is a test, right? It's a lab mission. Sometimes they may not generate, but let me generate some IO here, and let me show you how the active request can be monitored. So these are all the databases running. One database is running, Oracle Prod. Let me connect to it, and let me take the backup. Okay, arm and target slash. Let me see, any backup is existing. List backup. Yeah, there is some backup. So let me delete it. I don't have much space in delete backup. Yes. Okay. So list backup. So backup is not there now. Now let me take the backup database just to initiate. Now let us see uh, list active request. Nothing is there. Nothing is there. Nothing is coming. If our luck is there, it will come, because this is already initiated. This is our test lab. Ideally, it should generate some list active request here. Let us go like this. List active request. Yeah, it's still going. Yeah, list active request. Yeah, see, it came here. So this is the active request. This is a queued for a disk read, backup IO, and database name is this one, and request number is this one. So list active request, you can keep the request number as well. Okay, and you can keep detail. So it will give all the details with all the attributes. Attribute name is 2037 and ASM disk group number and DB name is vehicle prod and file type is data file and IO bytes this much processed so far, and this is a grid disk is processing and instance number from which instance the backup is initiated, this one, and request state is this one queued for, and IO type is cache get. So like this you can see the still the backup is going on. You can see the request like this. Okay, so these are all the active requests. If somebody asks in the interview what is active request, you can tell that it's a client IO request that are being processed by SL. Okay, so at instance level, database level, ASM level, and cell level, if any client is doing anything, so that is treated as an active request. Active request, you can see all these fields. Okay, so yeah, so you can see list active request and a request number. And in detail, you can see we have given this also, or where IO type, predicate pushing in detail. So this also you can see like IO type here it is a predicate pushing means in the where class you will see predicate pushing, right? The condition in the where class we call it as a predicate pushing. If you want to see cache put means arm backup. The arm backup is a cache put. So you can see like this, maybe you will get it or not. Where IO type is cache put detail. Let us give this here. Okay. So where IO type equal to, so let us remove this and let us put. You may get or may not get here, but this is already being processed. Let's stack to require IoT equal to cache get IO type detail. So 2037 where IO type equal to 37. Yeah, you got it right. So like this. So these are all the no. This is active request explanation. Okay, not required much because you need to know what exactly the active request, and you need to know that there is a there is a way that we can see the active request in the cell. That's it. Okay, now let us go to alerts. So this is important. So what do you mean by alerts in Exadata? So mostly if you are currently working on Exadata, you might have issued this alert history command n number of times. Okay, so what this alert history command will tell you? Okay, alert history command will tell you like the warnings and critical errors that are listed in the particular cell. So if alert history, if it is flagging something like if there is a disk fail, let us say, that you will see in the alert history when exactly it failed and where it is failed, all this stuff. And let us see alert history here as well. Cell CLI alert history, list alert history, list alert history. You see, there is one critical error here. There is one critical error here, and the alert history number is number one. So list alert history, you can get the details also. One detail. Okay. So these are all the details. So alert action, errors in some so and so file location and trace file. So this can be done as shown below. So like this, if a disk is failed, you can see some number for that disk failure and when it begin time, and all this you can see all this when the disk failed, what all this stuff. And even if the disk is replaced, once the field engineer comes to your data center and if he replaces the disk, at that time also you can see the disk is replaced with the timestamp. So all that it will you will get it from the alert history. So this is very important. So list alert history where severity equal to critical and examined by somebody. Maybe in your team you can own the alert history with you. Like Here, list elasticity where severity equal to critical and examined by Gautam. Here, examined by Gautam. I have changed this. You can give Gautam here. Okay. So let us say in your team, John, he wants some alert number, alert sequence ID. He is working on that. So he can flag this as a examined by, so that you can come to know, yes, this is being looked into by John or Gautam or like that. Okay. So you can alter this. You can remove this flag also. Okay. So like alter alert history command, you need to issue this command alter alert history one examined by null. If you give, so there will be nobody then. So let me say this one and examined by null. Okay. So successfully altered. Now you can see this one uh, examined by Gautam. It will show nothing because there is no Gautam, right? So now if you see the critical one, so this one and critical detail, if you see examined by will not be flagged by anybody. Examined by. Again, you can see alter alert history examined by some John. Okay, so if you see this successfully altered, and you can see list alert history critical detail examined will be John. So this is a stateless alert, no need to worry. So what is the stateless and stateful alerts? Okay, so stateless alert means represent a point in time event that do not represent a persistent condition. I mean it will never occur again. Okay, if it is stateful, so it will occur, and Exadata, it knows which is stateful and which is stateless. It flags it as a stateful and it will check after some time. And subsequently, the next state will also be the same. Then the error will, we can say that disk is really damaged. If the disk is damaged, let us say that's a stateful alert. After some time, it will again change if it is still in damaged state or not. So stateful alert must be, it will detect whether the state has changed or not. Sometimes there may be some false positive, and like even if the disk is not failed, it shows failed, then Exadata, it will flag it as a stateful alert. After some time it will check whether disk is really failed. If it is continuously failing, then it will treat it as a disk fail. So that is a stateful alert. Stateless means it knows sometimes there are some we no need to put concentration on the some alerts. So these are stateless alerts that will be taken care of by Exadata. Okay. Yeah, this is regarding alerts. And the last one is Exadata metrics. So Exadata metrics, what does it mean by a metric? Metric is nothing but, let us say, your body temperature is a metric of you, right? So like that. So here also metric, you can every object, the cell is an object, cell disk is an object, grid disk is an object in cell CLI. Every object has some metrics. Okay, if you want to see what are all the metrics available in Exadata, you can give list metric definitions. See, these are all the metric definitions. These are all the metric definitions. Some are related to cell disk, some are related to grid disk, GD for grid disk, like this, right? So if you want to see the metrics related to the grid disk, you can issue this one. Metrics related to grid disk. These are all metrics related to grid disk. And metrics, if you want to see what are all the columns in that, then you can see detail. So columns are name, description, metric type, and objective, object type, and unit. Unit is IO request, object type is a grid disk, and metric type is a cumulative. It's like a cumulative or rate or instantaneous. Like these are all the different types of metrics. Instantaneous, or it's accumulative over the time. It will show the it will show the value like number of megabytes over a time. That is accumulative. Okay, and instantaneous at that moment. And a rate means per second how much MB. So metrics are three types, either a rate or cumulative or instantaneous. Okay, so like this, you can see, you can observe the metrics in Exadata, and one of the metrics is metric current. I mean current temperature. So current temperature of the cell is this one, cell temperature, cell temp. It is not showing any metric. Why? Because this is not a real mission. This is a lab mission, so it is not showing any temperature metric. Current metric, how much for the temperature is this much. Okay, so the date is this much. This is the date. So metrics are nothing but the instantaneous values, or the rate, or the cumulative values of any object in the cell. Object means cell or grid disk or what. These are all the objects. These are all the object. Even file system is an object. See, FSUT, file system utilization. CL stands for cell. So you can see cell file system utilization. Cell file system utilization, like OPT is 87%. You exit and see, exit TM minus H, OPT is 87%, and slash is 27, and 6% there 0. All these four details you will see even at cell level using file system utilization metric. Okay, so again I'm telling you, in real time, when you do your job, you mostly come across these alerts only. You will not come across metrics or active requests. Okay, but still you can go and see. You can describe all this, like you can describe metric current definition, or you can describe cell, or you can list metric definition. All this stuff you can play around. And you know now what is active request? Active request is an object, and it has the attributes. These are all called attributes. This is called object in Exadata. This object is like a view or a table in your SQL place, and these attributes are like columns in the SQL place. SQL place. And when an active request is being processed, you can see like active request like backup IO or something like that. You can get the details also. The same happens with alert history. Alert history also has some number. So that number you can own it, like examined by like that. And you can filter. If the alerts are more, you can drop the alert history all. At any time, you can drop the alert history. And immediately, again, if the issue is persistent, again this list alert history will list that error. Let us say one disk is dropped, that is not replaced yet, so you can drop the drop alert history, no problem. That failure of the disk, that error message, again it repopulate in list alert history after some time, right? So you can drop the alert history at any time, no problem. Okay, and metrics again. So metrics is like a instantaneous, or rate or cumulative value of any metric associated with the objects such as cells, cell disks. Like best examples are temperature and file system utilization. So this completes lecture 16, very short lecture, and 17 also very short lecture, IPMI, DMI, decode, and ADR. So why I taught this active request alert metrics, because you need to know as an Exadata architect, you need to know what are all active request alerts and Exadata metrics, under monitoring, because under monitoring only you will monitor active request, you will monitor alerts, and you will monitor Exadata metrics. And the last section of monitoring is this IPMI, DMI, decode, and ADR. So we will see in the next lecture. So yeah. So thank you guys. This completes lecture 16. So we will meet in the next lecture. Thanks. Bye.